All right. Let's go even deeper into Thornthwaite's 1931 classification and break it down into the simplest terms, focusing on every key point. What is Thornthwaite's 1931 classification? Imagine the world has many types of climates, like deserts, rainforests, and snowy regions. In 1931, C.W. Thornthwaite, a scientist, tried to create a system to label and separate these climate types. How Thornthwaite's classification is similar to Köppen's. Thornthwaite's system is somewhat similar to Köppen's climate classification, which is another way scientists grouped climates. Here's how they're alike. 1. Letter symbols for each climate type. Like Köppen, Thornthwaite used letter combinations to represent different types of climates. For example, he might label a climate type as A or B, and sometimes add other letters to show a subtype. 2. Focus on vegetation. Both Thornthwaite and Köppen believed plants were a great clue to understanding climate. If you see cactus plants, you might be in a dry area. If you see lots of lush green plants, the area might be wet. So both systems look at what plants naturally grow in different areas to help identify the climate. Number 3. Using numbers for boundaries. Both systems use numbers and measurements to draw clear lines between one climate type and another. For example, they might say if the average rainfall is below 10 inches, it's a dry climate. How Thornthwaite's classification is different from Köppen's. 1. Precipitation efficiency, rainfall efficiency. Thornthwaite didn't just care about how much it rains, but how useful the rain is to plants. Why does this matter? Let's say it rains 10 inches in a month, but it's very hot and half the water evaporates quickly. This rain might not help plants as much. So, precipitation efficiency is a way to measure how helpful rainfall is for plant growth by comparing rainfall with evaporation. 2. Thermal efficiency, temperature efficiency. Thornthwaite also looked at temperature, but focused on how it affects plants. Thermal efficiency means checking if the temperature is good for plants to grow. Plants need the right amount of warmth to thrive. Too cold or too hot isn't ideal. By adding this idea of temperature efficiency, Thornthwaite could separate regions based on whether they were warm enough for plant life. Important features of Thornthwaite's 1931 classification. 1. Moisture. Water is the main factor. Moisture is primary. Thornthwaite focused mainly on how much water moisture is available in an area. This makes sense because water is key for plants. He even created a number system, like the TE index, to show if the area has enough water. For example, he used the T index of 31 to separate cooler climates like taiga forests from warmer ones. Number 2. More climate types than Köppen. Thornthwaite's system divided climates into 3 times as many types as Köppen. Why so many types? Thornthwaite's system is more specific. If Köppen might say cold climate, Thornthwaite might split it into more detailed types, like very cold, medium cold, slightly cold. 3. Fewer symbols with clear meaning. Even though Thornthwaite has more types, he used fewer letters to label them. His letter system was simple, so you could tell what type of climate it is just by looking at the letter code. 4. Hard to draw exact boundaries, because Thornthwaite was looking at detailed things like precipitation effectiveness, how much rain is helpful, and temperature efficiency, how useful the temperature is. It made drawing clear boundaries between climates harder. For instance, it's tricky to say exactly where a semi-dry area ends and a semi-wet area begins. Number 5. Not enough data. In Thornthwaite's time, it was difficult to get all the data on rainfall and evaporation rates for every place. Some weather stations didn't measure evaporation rates, how quickly water evaporates, which made it hard to apply his system everywhere. Weaknesses or limitations of Thornthwaite's 1931 classification. 1. Doesn't allow easy comparison. Just like Köppen's, Thornthwaite's system isn't perfect for comparing different places directly because Thornthwaite's system only estimates factors like precipitation effectiveness, how useful rain is. It's hard to get exact measurements. 2. Less useful for weather scientists. This classification is very helpful for geographers who study the Earth's features, botanists who study plants and zoologists who study animals. It helps them understand where certain plants and animals can survive. But meteorologists who study weather and climatologists who study climate in detail find it less helpful because Thornthwaite's system doesn't show the full picture of how all weather elements work together. Why Thornthwaite's classification still matters. Even with its limitations, Thornthwaite's system was important because 1. Added depth to climate classification. By focusing on moisture and temperature's role in plant growth, Thornthwaite's system gives us more detail than Köppen's. 2. Helped understand life and climate together. This system was helpful for understanding where plants and animals could live. 3. Laid groundwork for future studies. His ideas influenced future scientists who kept exploring how climate and ecosystems interact. Summary in simple words. Thornthwaite's 1931 classification is a way of grouping climates by 1. How much useful water, moisture, an area has for plants. 2. How suitable the temperature is for plants to grow. It's like Köppen's system, but with a focus on water effectiveness and temperature. This classification helps understand where certain plants and animals can thrive, even though it's not as helpful for studying daily weather. Thornthwaite's system may be more complicated, but it opened new ways to think about how climate affects life. All right, let's break down Thornthwaite's 1948 classification in the simplest way possible. We'll go through it piece by piece, focusing on the key points and adding examples to make it easy to understand. What was Thornthwaite's goal? Thornthwaite wanted a system to identify the climate of any place by focusing on 1. Potential evapotranspiration PE. How much water plants lose through evaporation and transpiration when they sweat water out. 2. Thermal efficiency. How much heat, warmth is present in a place. 3. Effective moisture. How much moisture is actually available for plants. 4. Seasonal variation. How moisture changes with the seasons. By measuring these things, he thought he could figure out what kind of climate, like wet, dry, hot, or cold, a place has. Thornthwaite's system, how it works. 1. Potential evapotranspiration, PE, and soil moisture. Imagine a place where it rains. Not all that rain is available for plants, though. Some water evaporates, turns into vapor, or transpires. Plants sweat it out. So Thornthwaite looked at how much water is left for plants after this loss, which he called potential evapotranspiration. 2. Thermal efficiency and temperature. Temperature matters because if it's warm, plants need more water. For example, in hot summers, plants need extra water to stay healthy. Thornthwaite included this by measuring how efficient the warmth, thermal efficiency, is in different seasons. 3. Seasonal changes in moisture. He noticed that some places have rainy seasons, lots of water, and dry seasons, little water. He looked at how moisture levels changed in each season to see if plants had enough water year-round. 4. Using math and symbols. Thornthwaite's method involved a lot of calculations. For example, he needed numbers to show how much water plants use and how much heat is available. He also used letter symbols to represent different climates, like Köppen. Criticism of Thornthwaite's 1948 classification. Even though Thornthwaite's system was new and interesting, it had some limitations. 1. No global map. Thornthwaite's system worked well in some areas, North America, but it was hard to apply it everywhere, so no one has made a world map using his system. Why? Different regions, especially the tropics and semi-arid areas, didn't fit as neatly into his categories. 2. Doesn't focus on vegetation boundaries. Unlike Köppen, who used natural plant boundaries, like where forests end and deserts start, Thornthwaite did not base his boundaries on vegetation zones. Instead, he focused more on water and temperature data, which sometimes didn't match exactly with plant zones. 3. Complicated calculations. Thornthwaite's method required a lot of math and calculations, which made it hard for people to use. Many students and scientists found it too complex, so Köppen's simpler system became more popular. Thornthwaite's big idea, the soil-moisture balance. One of Thornthwaite's major contributions was the soil moisture balance. This means water balance. He wanted to figure out if plants have enough water in the soil and if there's any extra water for rivers or underground sources. Not just rainfall. He knew that just looking at rainfall wasn't enough. Rain might fall, but temperature and evaporation affect how much water plants actually get. Evapotranspiration! By measuring evapotranspiration, he checked how much water plants lose and need based on temperature. Example, imagine a garden. If it rains 10 inches, but the temperature is very high, the soil dries up faster. Plants lose more water and might still need more water, even though it rained. Thornthwaite's idea was that you can tell if a climate is wet or dry by comparing the rainfall water in with the water plants actually need water out. Why Thornthwaite's system is important. Even though his system isn't as popular, Thornthwaite's ideas were very useful. 1. Introduced evapotranspiration in climate studies. He was the first to look at how much water plants lose and need, which helps with water management today. For instance, farmers can use this idea to see if crops need more watering. 2. Water use planning. His method helps in places where water is scarce by measuring water needs, especially in dry or semi-arid regions. Key takeaways. Simple summary. Thornthwaite's 1948 classification is a climate system that focuses on 1. Water needs of plants, how much water plants get versus lose. 2. Temperature's role in changing water needs. 3. Seasonal changes in moisture. Limitations. 1. It's complex and involves too many calculations. 2. It doesn't match plant boundaries everywhere, especially in tropical and dry regions. 3. No global map could be made because it's hard to apply everywhere. Importance. 1. Introduced water balance ideas, which are used today in agriculture and water management. 2. Helped scientists understand how temperature and moisture together affect plant growth. In short, Thornthwaite's system is very detailed but complicated. It works well in some places and adds a lot to our understanding of water needs, but it's not as easy to use as Köppen's system. All right, let's break down Trewartha's classification step by step in the simplest way possible. This classification is a way to organize and understand the different climates around the world, making it easier to know what to expect in various regions. Trewartha built on earlier systems like Köppen's to make a simpler and more user-friendly version. Let's go through each part. Number 1. Who was Trewartha? Glenn T. Trewartha was an American scientist who studied climate, the long-term weather patterns of different places. He looked at older climate systems like Köppen's classification and thought they were too complicated for most people. Number 2. Why Trewartha created a new classification? Problem. Earlier systems, like Köppen's and Thornthwaite's, had many small categories of climate types, making them hard to use and remember. Goal. Trewartha wanted a simpler system with only a few main climate types, so that anyone could understand it without needing to memorize a lot. 3. What is Trewartha's classification? Basic idea. Trewartha's classification groups climates based on simple ideas about temperature and precipitation, rain and snow. Mixed method. It combines two ways of classifying climate. Empirical, based on measurements like temperature and rainfall. Genetic, based on what causes the climate, like ocean currents or wind patterns. This way, Trewartha's system doesn't just look at numbers, but also considers what shapes a place's climate. 4. How Trewartha made it simpler. Fewer main types. Trewartha only used around 15 main climate types, much less than the other systems. This way, people only need to know a few basic types. Option for more detail. He kept the main types broad, but you could add such subtypes if needed, like smaller categories within each climate. For example, main climate type, temperate, mild, not too hot or too cold. Subtype, warm temperate, closer to the equator, or cool temperate, closer to the poles. Now 5. Examples of Trewartha's climate types. Let's look at a few examples of how Trewartha's classification works. 1. Tropical climate, hot all year round, high rainfall, especially near the equator, example, Amazon rainforest. 2. Temperate climate, mild summers and winters with more variation in temperature, rain spread out over the year, example Western Europe. 3. Arid climate, very dry, little rainfall, can be hot like deserts or cold like tundra, example desert. 6. Benefits of Trewartha's system, easier to learn and remember, with only a few main types. It's simpler than Köppen's or Thornthwaite's, which had a lot of detailed types. Flexible, you can add extra details if needed, like subtypes, but the main types are broad and easy to understand. Useful for beginners. It's a good way for students or anyone new to climate study to get a general sense of the world's climates. 7. Why Trewartha's system stands out. Balanced approach. Trewartha combined empirical, data-based and genetic, cause-based methods, making his classification balanced and understandable. Modern influence. Even today, Trewartha's approach influences how we study and explain climate because of its clarity and simplicity. Recap of Trewartha's classification. Trewartha's system is a simplified way of understanding climate. It has a few main climate types, around 15, with the option for more detailed subtypes if needed. Combines two methods, empirical and genetic, making it more balanced than just looking at data or causes alone. Easy to learn and useful for beginners who want a basic understanding of the different climates around the world. By focusing on simplicity and clarity, Trewartha's system makes it easy to classify and understand the different climates without needing complex calculations or too many types. All right, let's break down Trewartha's climate classification step by step in the simplest possible way. Imagine we're learning about why Trewartha created this system, what he wanted it to do, and how he divided the world's climates. Why did Trewartha create this classification? Trewartha thought that understanding the climate was important for many people. Geographers, who study places, biologists, who study living things, who grow crops. These people need to know what the climate is like in different places because it affects things like where plants grow and what kind of animals can live in certain areas. Trewartha felt that the old climate systems were too complicated. He wanted a system that showed real climate data, like temperature and rainfall, was easy to understand and use. 2. The two types of climate classification. In the world of climate science, there are two main ways to classify or label climates. 1. Empirical classification. This uses real observed data like temperatures and rainfall. It looks at the numbers and describes what happens in the climate without worrying too much about the why behind it. Trewartha preferred this type because it's based on actual data, which makes it practical and useful. Number 2, genetic classification. This tries to explain why a place has a certain climate. It focuses on things like how winds, oceans and mountains shape the climate. Trewartha liked this because it makes climate study more interesting and adds a scientific quality that helps students understand more deeply. Trewartha's approach. Trewartha believed both methods were important. He felt that while empirical classification should come first because it's simple and data-based, genetic ideas should be used when possible to help us understand more about the why behind each climate. 3. How did Trewartha classify climates? Trewartha took some ideas from another system called Köppen's classification, but he made it simpler and clearer. He used the two most basic weather elements, temperature, how hot or cold it is, precipitation, rain and snow. How for Trewartha's 6 climate groups. Trewartha divided climates into 6 big groups. 5 are based on temperature and 1 is based on precipitation. Group A, tropical climates, warm or hot all year. Rainfall, heavy rain, especially in certain seasons. Example, Amazon rainforest, it's hot and it rains a lot. Group B, dry climates, precipitation, very little rain or snow. Temperature can be very hot or very cold. Example, Sahara Desert. It's dry and there's very little rain. Group C, mild mid-latitude climates, mild winters and warm summers. Rainfall, rain in winter, summers may be dry. Example, Mediterranean area, like parts of California or Italy. Group D, severe mid-latitude climates, temperature, cold winters, hot summers. Rainfall varies, but there's often snow in winter. Example, Canada, Russia. These areas have cold, snowy winters and warm summers. Group E, polar climates, temperature, cold all year with very little warm weather. Precipitation, very little rain or snow. Example, Greenland or Antarctica. Group F, highland climates, where high mountains. Climate cooler than nearby areas because of high altitude height. Example, Himalayas. Even if the nearby area is warm, the high mountains are cold. Act 5. Why True Author's system is useful. Practical. Since it's based on real numbers like temperature and rainfall, it gives a clear picture of what to expect in each climate. Simple. With only 6 groups, it's easy to remember and apply. Good for many professions. This system is useful for farmers who need to know about rain and temperature, scientists and students who are studying world climates.
Summary of True Author's climate system.
True Author made his climate system simple and practical. He focused on what we actually see, temperature and rainfall, making it a system that's easy to understand but still useful for anyone studying or working with climates around the world. By using real data and explaining the why behind each climate, True Author's classification helps us understand our world's climates in a balanced, clear way. All right, let's break down tropical humid climate in the simplest way, step by step. 1. What is tropical humid climate? Location. This climate is found near the equator in areas 20 to 40 degrees north and south of it. Think of places like the Amazon rainforest in South America or parts of Southeast Asia. Weather, it's warm or hot all year long. There is no winter season here. Temperature, the temperature stays uniformly high, meaning it doesn't change much between seasons. Even in the coldest month, it's still warm. Rain! There is plenty of rain throughout the year. This helps keep the area lush and green with lots of trees and plants. No frost. It never gets cold enough to frost. Frost is when water freezes on surfaces like plants. It's too warm for that to happen. Temperature details in places near the ocean, called marine locations. Even the coldest month has a temperature of 18 degrees, about 64 degrees Fahrenheit or higher. This is still quite warm, like a mild summer day in other parts of the world. Subdivisions of tropical humid climate. Tropical humid climate can be divided into 2 main types. 1, tropical rainforest climate. 2, tropical monsoon climate. Let's go through each one. A, tropical rainforest climate. Example, the Amazon rainforest in Brazil. Rain. This climate has rain almost every day of the year. Temperature, warm all year, without much change from seasons into season. It might be 26 to 28 degrees, about 79 to 82 year round. Because of all the rain and warmth, this area has thick forests with lots of trees, plants and animals. B, tropical monsoon climate. Example, Mumbai, India. This climate has a very rainy season, monsoon, and a dry season. During the rainy season, it can rain a lot, but during the dry season, it might not rain for months. Temperature. It's still warm all year, but the amount of rain changes with the season. Plants. There are lots of plants, but they have to survive both wet and dry periods. Why is tropical humid climate important? This climate type is home to many plants and animals. The rainforests here produce a lot of the world's oxygen. Many fruits and foods we eat, like bananas and mangoes, come from these areas. Summary of tropical humid climate. In summary, tropical humid climate stays warm all year, no winter, has plenty of rain, sometimes all year, sometimes seasonal, is home to thick forests and lots of plants and animals. This climate type is found close to the equator and supports some of the most important ecosystems on Earth, like the Amazon rainforest. Let's go deeper into tropical wet climate and tropical wet and dry climate, A double, in the easiest way possible. 1.
Tropical wet climate.
Where is tropical wet climate found? This climate is very close to the equator, the middle of the Earth. It usually stretches about 5 to 10 degrees north and south of the equator. Sometimes it reaches up to 15 to 20 degrees near the eastern edges of continents. What's special about this climate? Temperature. It's warm all year. There's no winter or cold season here. Rainfall. There's a lot of rain all year round with no dry season. This means that there are fewer than 2 months with low rain in a year. Air pressure. The air pressure stays low. Low pressure helps bring in warm, moist air from nearby areas, causing it to rain a lot. Why is it called the tropical rainforest climate? This climate supports thick rainforests with tall trees and plants. There's so much rain and warmth that plants can grow fast and thick. Example, the Amazon rainforest in South America has this climate. Main points to remember: constant warmth and frequent rain, dense forests with tall trees and many animals, low pressure and steady winds from the equator. Tropical wet and dry climate. Where is tropical wet and dry climate found? This climate is also in tropical areas, but a bit farther from the equator than the tropical wet climate. It's found where there's a mix of wet and dry seasons. What's special about this climate? Temperature. It's warm all year, but unlike R, there is a clear wet season and dry season. Rainfall. During the wet season, it rains a lot. During the dry season, it barely rains at all. Winds and air pressure. Dry season, when the sun is low in the sky, winter. This area gets dry trade winds. These winds blow from high pressure areas and bring dry air. Wet season, when the sun is high in the sky, summer, the intertropical convergence zone, ITCZ, and equatorial westerlies bring in rain. Why is it called savanna climate? This climate supports savannas, which are large grasslands with some scattered trees. There are trees, but they are spread out with a lot of open space and grasses in between. Example, the African savannas like the Serengeti have this climate. Main points to remember: warm all year, but has separate wet and dry seasons. During the dry season, it's controlled by dry trade winds. Savannas with grasslands and scattered trees grow here. Comparison of R and A dole climates: climate type, temperature, rain pattern, vegetation type. Example year: wet season, dry season. R, tropical wet, warm all year, rain all year, dense rainforests, Amazon rainforest. R, tropical wet and dry, warm all year, wet season plus dry season, savannas with grasslands, African savannas. Summary of both types. R climate, always wet and warm, supports rainforests and has no dry season. R climate, warm all year, with wet and dry seasons, supports savannas with grasses and scattered trees. In the simplest way, tropical wet R is warm and rainy all year and has rainforests. Tropical wet and dry is warm all year but has a wet and a dry season and has savannas. Let's go through the subtropical climate C, focusing on the details in the simplest way possible. Subtropical climate C. Where is this climate found? The subtropical climate is found between 20 degrees and 40 degrees latitude, a bit above and below the equator. You'll see it in parts of southern US, southern China, Japan, the Mediterranean region, and parts of Australia. What's special about subtropical climate? Warm temperatures. It's warm for most of the year, about 8 months of temperatures above 18 degrees Celsius. Winters can be cooler, but they don't get as cold as in other regions. Frost. Near oceans, marine locations, no frost in winter. Inland, continental locations, there can be some frost in winter. Types of subtropical climate C. Subtropical climates are split into 2 types based on how rain is spread throughout the year. Type 1, subtropical humid climate. Where is it found? Found on the eastern side of continents. Examples, southeastern US, Florida, Georgia, and parts of eastern China. What's special about subtropical humid climate? No dry season. It rains all year round with no period where it's completely dry. More rain in summer. Summer, lots of rain due to unstable, warm, moist air. This is because the air from a nearby high-pressure system brings moisture and causes rain. Winter, there's still rain, but it's brought in by temperate cyclones, big rotating storm systems. Summer has more rain than winter. Summary of CFW, subtropical humid, warm year-round with rain all year. More rain in summer than winter, found on the eastern side of continents. Example, southeastern US, like Florida, and eastern China have this climate. Type 2, subtropical dry summer climate. Where is it found? Found on the western side of continents between tropical and cooler temperate regions. Examples, California in the US and parts of the Mediterranean like Italy and Spain. What's special about subtropical dry summer climate? Dry summer, rainy winter. Winter, this is the rainy season, like with rain coming from temperate cyclones. Summer, very little or no rain at all. It's almost dry. Stable air. In the summer, this climate is affected by a high-pressure system over the ocean. This system brings stable air, which prevents clouds from forming and keeps the summer dry. Transition zone. This climate type is like a transition between tropical dry climates closer to the equator and cooler, temperate climates further from the equator. Summary of seas. Seas, subtropical dry summer, warm year-round, but with dry summers and rainy winters, found on the western side of continents. Example, California and Mediterranean regions, like parts of Spain, Italy. Comparison of the two types, climate type, summer weather, winter weather, rain pattern. Example regions. Example regions. CFW, wet, rainy, still rainy, year-round rain, southeastern US, eastern China. Dry, almost no rain, rainy. Dry summer, wet winter, California, Mediterranean. Summary of subtropical climate C. 1. Warm most of the year. 2 types. CFW, humid, rains all year with more rain in summer. Dry summers and rainy winters. In simple words, CF is warm with year-round rain, especially in summer. CISH is warm with dry summers and rainy winters. Let's go through the temperate climate D step by step in the simplest way. Temperate climate D. Where is temperate climate found? The temperate climate is located in the middle latitudes between the warmer subtropical climate and the colder boreal or polar climate. These areas experience moderate temperatures that are neither extremely hot nor extremely cold all year round. What's special about temperate climate? Temperature range. Temperatures are generally between 10 degrees Celsius for 4 months of the year and can go up to 10 degrees Celsius for 8 months. 8 months. Summers are warm and winters can be mild or very cold depending on the specific type. Because of the large range in temperature, both hot summers and cold winters can be found in this climate. Weather events. Snow often covers the ground in winter. This climate can have cold waves, heat waves, blizzards and heavy rainfall. Weather can change quickly and sometimes without a clear pattern. Rainfall, precipitation. Rain falls all year with most of it during summer. Types of temperate climate. There are 2 main types of temperate climates, each found in different parts of the world and with unique characteristics. 1. Dew. Temperate marine climate. Where is dew found? Found on the western windward sides of continents. Examples, Western Europe, like England, Ireland, Pacific Northwest, US and Canada. What's special about dew climate? Mild winters. Winter temperatures are not very cold. They're usually around 0 degrees Celsius or above all year, so no extreme freezing. Year-round rain. This climate is humid, meaning there's enough moisture for rain. Rain falls all year without a dry season, providing consistent water. Summary of dew, temperate marine, mild winters, above 0 degrees Celsius year-round. Rain all year, making it humid, located on the western sides of continents. Example, Western Europe and Pacific Northwest in North America. Part 2. DC temperate continental climate. Where is DC found? Found inland, away from the ocean, in the middle latitudes. These are places more in the center of continents. Examples, central and eastern US, parts of Russia, Canada. What's special about DC climate? Hot summers and cold winters. This climate has extremely cold winters and hot summers because it is away from the ocean's influence. The range of temperature is large due to both summer heat and winter cold. Snow and quick weather changes. Snow covers the ground in winter. Rapid changes in weather, like cold fronts and heat waves, are common. Rain all year. Rain falls in all months, but is heavier in summer when it's warm. Summary of DC temperate continental, hot summers and very cold winters. Snow in winter and frequent quick weather changes. Rain all year, especially in summer. Example, central and eastern US, parts of Russia and Canada. Comparison of the two types. Climate type, summer weather, winter weather. Rain pattern, example regions. DC continental, more in summer. Do mild rain all year, humid Western Europe, Pacific Northwest. Continental, hot, very cold, rain all year, more in summer, central US, Russia, Canada. Summary of temperate climate D. 1. Temperate climate exists in the middle latitudes. 2. Two types. Marine, mild all year with rain in every season, found near oceans. DC, hot summers, cold winters with snow and rain, found inland. In simple words, do stays mild and has rain all year. DC, hot summers and cold winters with snow and rain, especially in summer. Let's go deeper into the boreal climate in a super simple way. I'll go slow and explain every part carefully, one step at a time. 1. Where is boreal climate found? Boreal climate is found up north, but not at the very top of the world. It's close to the Arctic, but not all the way there. Imagine Alaska, northern Russia, and parts of Norway. These are places with boreal climates. Think of big, snowy forests and cold lands with fewer people. It's often very cold and covered in snow during winter. 2. What does continental climate mean? When we say it's a continental climate, we mean it has big temperature changes between summer and winter. In these areas, summer is very short and cool. Winter is long and very, very cold. 3. Temperature in boreal climate. Summer temperature. In summer, temperatures can go up to 10 degrees or a little more. 10 degrees Celsius feels like a cool spring day where you might want a light jacket. This only lasts for 1 to 3 months of the year. That's it. Winter temperature. The rest of the year is cold, way below 10 degrees Celsius. Winter temperatures can drop to minus 30 degrees or even lower. At these temperatures, it's freezing and there's snow on the ground for months. Big temperature changes. The difference between summer and winter temperatures is huge. Summers are cool, but winters are freezing, much colder than summer. Now, 4. Rain and snow, precipitation. Boreal climates are called humid, but they don't get a lot of rain or snow. Precipitation happens all year round, so it rains or snows every month. Most rain and snow happen in the summer months because warm air can hold more moisture, more water than cold air. Even though it's cold and snowy, the total amount of rain and snow over the year is still pretty low. Number 5. Natural vegetation plants. Boreal climates are home to coniferous forests. Coniferous trees are special. They have needles instead of leaves. Examples include pine trees, spruce, and fir trees. These trees are strong and adapted to survive cold temperatures of winter, short summers where they grow a little before winter comes again. These forests are sometimes called taiga forests. Now 6. Population and life in boreal climate. Boreal climates are hard places to live because of the long, cold winters and short summers. Few people live here. This is called a sparse population, meaning spread out and not many people. The people who do live in boreal climates may depend on hunting, fishing, and forestry, cutting down trees for work and food. It's not like a big city. Houses are far apart, and there's a lot of natural land and wildlife. 7. Other name for boreal climate. Boreal climate is also called subarctic climate. Subarctic means it's almost in the Arctic, the very cold region at the top of the world, but it's not quite there. 8. Examples of boreal climate areas. Northern Canada. In Canada, there are large forests and lakes that freeze over in winter. Siberia in Russia. Siberia has big forests and a very cold winter. In both places, summers are short and cool, and winters are long and very cold. 9. Animals in boreal climates. Animals in boreal climates like moose, wolves, bears and foxes are adapted to handle the cold. They have thick fur, and some even hibernate, sleep through the winter to survive. Extra information. Why boreal forests are important. Boreal forests store a lot of carbon. This helps reduce global warming. They keep the Earth's climate in balance by absorbing carbon dioxide, a gas that warms the planet. So the boreal climate is unique. It has cool summers, very cold winters, and huge forests of pine trees. Not many people live there because it's hard to handle the cold. This special climate makes places like northern Canada and Siberia different from the rest of the world. Absolutely. Let's break down polar climates and the tundra climate further so everything is crystal clear. 1. What is a polar climate? Polar climates are found in places very close to the North Pole, the northernmost part of Earth. These places stay extremely cold all year long. Unlike many other places on Earth, they don't have a real summer season. Even during the warmest months, it's still very cold. Temperatures never go above 10 degrees Celsius, even in the warm months. Polar climates are mostly found in the northern hemisphere, upper half of Earth. Nab 2. Types of polar climate. Tundra climate. Tundra climate is a type of polar climate. In tundra climates, the land is flat, icy, and very cold. No trees grow here because it's too cold for them to survive. Only simple plants like grasses, mosses, and lichens, small, tough plants, grow in tundra areas.
Number 3.
Where can we find tundra climates? Tundra climates are found along the coasts of the Arctic Ocean, on many islands in the Arctic, such as parts of Iceland and Greenland. These are all in the northern hemisphere because there's no tundra in the southern hemisphere, lower half of Earth. The reason? In the southern hemisphere, there's mostly ocean near the South Pole, not much land for a tundra to exist on. 4. Temperature in tundra climate. In tundra climates, the warmest month is only between 0 degrees Celsius and 10 degrees Celsius. That's about the temperature of a fridge. The temperature doesn't change much throughout the year. It stays cold. Even in summer, the temperature barely rises above freezing, 0°5. Permafrost, frozen ground. Permafrost is the term for ground that stays frozen all year. In tundra climates, the ground is frozen deeply and stays that way. During summer, only the top layer of soil thaws slightly, enough for some tiny plants to grow. Below this thin layer, the soil stays hard and frozen all year. This frozen ground makes it hard for plants to grow roots, which is why only small plants can survive here. Number 6. Vegetation. Plants that survive the cold. Since it's so cold, trees cannot grow in tundra climates. Instead, the tundra has special plants that can handle freezing temperatures. Grasses. These are small soft plants that cover the ground. Mosses. They are tiny plants that grow in a soft spongy layer. Lichens. These are unique plants that often grow on rocks or soil and are very hardy. These plants are tough enough to survive the cold and can live with little nutrients because the soil isn't very rich. Precipitation, rain and snow in tundra climate. Precipitation means any water that falls from the sky, like rain, snow, sleet, etc. In the tundra, there is precipitation throughout the year. Most of the time, this precipitation is in the form of snow. Summer has the most precipitation because it's a bit warmer, so some of it may fall as rain. In winter, it's so cold that it only snows, and the snow is very dry and light, like powder.
8.
Why tundra climates are important. The tundra climate is a unique and delicate environment. Even though it's cold, many animals and plants have adapted to survive in this tough climate. Tundra areas store a lot of carbon in their frozen ground, permafrost. If this ground melts, it can release greenhouse gases, which can warm the earth further. Animals like polar bears, Arctic foxes, and reindeer have adapted to live here. For example, polar bears have thick fur and fat to keep warm. Arctic foxes can change the color of their fur, white in winter, brown in summer, to stay hidden from predators. Example of tundra climate in real life. Imagine a place like northern Canada or northern Russia. The land is flat and covered in snow most of the year. No trees can grow there because of the frozen ground. Only low plants like mosses and grasses cover the land. There's very little rain or snow, but whatever falls stays frozen. Summary. Tundra climate is an extremely cold type of climate found near the Arctic Ocean. The ground is frozen, permafrost, and only a thin layer of soil thaws in summer. No trees grow, only tough small plants survive here. Animals like polar bears and Arctic foxes have special adaptations to live in this harsh, cold climate. Snow and light rain fall throughout the year, but most precipitation happens in summer. This is the tundra climate, a cold, snowy, flat landscape with unique plants and animals adapted to survive its icy conditions. All right, let's go deep into understanding ice cap climate in a very simple way, step by step. Number 1, what is ice cap climate? The ice cap climate is one of the coldest climates on Earth. In an ice cap climate, all the months are below freezing. Surges at 30 degrees Celsius. This means the temperature never rises above freezing. It's cold all the time, day and night, all year long too. Where is ice cap climate found? Ice cap climate is only found in 2 places on Earth. Greenland, a big island covered in ice in the northern part of the world. Antarctica, a huge icy continent at the South Pole. Together, these areas cover more than 15.5 million square kilometers. That's about 1/10 of all land on Earth. 3. What does the ice cap climate look like? The landscape is covered in ice and snow all year. There are no trees, no flowers, no plants, and no grasses. Nothing grows here because it's far too cold. The land is just ice and snow stretching for miles and miles. 4. Temperature in ice cap climate. The temperature never goes above freezing, even in the warmest months. It stays cold enough that ice never melts here. The snow and ice just build up over time, creating thick layers. 5. Precipitation. Snow in ice cap climate. Precipitation means any water that falls from the sky, like rain or snow. In the ice cap climate, there's only snow, no rain. The amount of snow that falls is small. It doesn't snow a lot. The snow that falls is dry, hard, and powdery, almost like sand. And matter 6, how does snow form here? It's a bit of a mystery where the snow in ice cap climates comes from. Scientists think it may come from cyclonic storms, big swirling weather systems that bring snow inland from the oceans. Most of the snow falls near the edges of the ice caps, close to the 7 surface inversions, super chilled air close to the ground. Because the ground is covered with ice, the air near the ground is very cold. This cold air sinks and stays close to the ground, creating what is called a surface inversion. In normal climates, warm air is usually close to the ground and cold air is above. But in ice cap climates, the air close to the ice is colder than the air above. 8. What lives in ice cap climate? In the ice cap climate, almost no life can survive on the land itself because it's too cold and icy. However, in places near the ice cap edges, some animals do manage to survive. Penguins in Antarctica, they live near the sea, not deep inland. Seals and polar bears near Greenland. These animals rely on the sea for food because the ice-covered land itself doesn't provide anything to eat. Number 9. Examples of ice cap climate regions. Think of Antarctica. It's a huge, white, icy land where temperatures are below freezing all the time. Snow falls sometimes, but not a lot. There are no plants, trees, or animals on the land, only ice and snow. Some animals, like penguins, live on the edges near the ocean. Now picture Greenland. Most of Greenland is also covered by thick ice. It's extremely cold and there are no forests, grass, or plants. Animals like polar bears live near the sea, not deep inland. Summary: ice cap climate. The coldest places on Earth found only in Greenland and Antarctica. Always freezing. Temperatures stay below freezing, even in summer. Nothing grows here. No plants or trees, only ice and snow. Dry snow. Snowfall is light and the snow that falls is dry and powdery. Surface inversion. Super cold air near the ground stays below slightly warmer air above. Wildlife. Very few animals can live here and they stay near the ocean for food. Ice cap climates are like nature's deep freezer. Nothing melts, nothing grows, and it's icy and cold all year. Only the hardiest animals survive near the ocean, and the icy land remains almost untouched by life. All right, let's break down dry climates even further to make everything as simple as possible. What is a dry climate? A dry climate is an area where there isn't much water coming from rain or snow. The water that does fall dries up quickly because of evapotranspiration. Evapotranspiration is evaporation, water turning into vapor from soil, lakes, rivers. Transpiration, water vapor coming from plants. In a dry climate, the water dries up faster than it's replaced by rain. This makes the climate very dry. Why is it hard to measure dry climates? No exact tool exists to measure how much water evaporates over large areas. Without this, it's tricky to know where a dry climate ends and a humid, moist climate. What makes dry climates special? Dry climates have unique features. 1. Clear skies. There aren't many clouds, so there's lots of sunshine. 2. Big temperature differences. Annual range, big difference between hot summer and cold winter. Daily range, big difference between daytime heat and nighttime coolness. 3. Low humidity. The air feels very dry with little moisture. 4. Little rain precipitation. They get very little rain or snow. This rain can vary greatly each year, so some years might have more rain and others might have almost none. Types of dry climates. Dry climates are divided into two main types based on how much rain they get. 1. BW, arid desert. These areas get very little rain. They are the driest places on Earth. Example, Sahara Desert in Africa. 2. BS, semi-arid, steppe. These areas get a bit more rain than deserts, but are still dry. Example, Great Plains in the USA. Boundaries between arid and semi-arid. The line between deserts, arid, and steppes, semi-arid, depends on annual rain. If the area gets half the rain of a humid area, it's a steppe. If it gets less than that, it's a desert. Example, if a humid area gets 40 centimeters of rain in a year, then a steppe would get around 20 centimeters of rain. A desert would get less than 20 centimeters of rain. Divisions of dry climates by temperature. Dry climates can also be split into groups based on temperature. 1. WR, hot deserts. These deserts are very hot and are found in the tropics or near the equator. Example, Sahara Desert in Africa where it's hot all year round. 2. BWK, cold deserts. These deserts are cooler and have cold winters. Example, Gobi Desert in Mongolia, which is cold in winter but still dry. 3H, hot steppes. Warm or hot semi-arid areas near the tropics. Example, savannas in Africa where it's warmer but not as dry as a desert. Summary, dry climates are places that lose water quickly and don't get much from rain or snow. They have clear skies, big temperature changes, and very dry air. Two main types, BW, desert, extremely dry, little rain. BS, steppe, a bit more rain but still dry. Further divided by temperature, hot deserts, very warm all year. Cold deserts, cold winters but still dry. Hot steppes, warm but with some rain. In short, dry climates are always low on water, leading to unique, harsh conditions that make these places very different from moist or humid climates. They have extreme temperatures, clear skies, and only a little rain.